So in question number 6, our x is normally distributed random variable. Okay, mu is given as 29, sigma standard deviation is given as 8, and we need to find value of x naught for this ABCD. Since this is normally distributed, we start by drawing a graph, bell-shaped curve. So you draw a bell-shaped curve. So this is our normal distribution. Our mean at the center, this is mu, which is 29. Okay, and our sigma is 8, standard deviation is 8. Okay, now we are asked to find x naught, okay, such that probability of x is greater than equals to x naught is 0.5. Now here, this is our x, okay, horizontal axis is x, and this is our f of x. So we need to find the value of x naught, okay, and your x naught is somewhere on the along the horizontal axis. Okay, let's say our x naught is somewhere here. We don't know it. It may be on the right side or left side. But what do we know? The probability that x is greater than this x naught is 0.5. Now, where do you think our x naught will be in this graph? So we need to locate that x naught. Okay, x naught is some value on this x-axis. It may be on the right of 29 or left of 29 or right of 29. But what is given to us? The probability that our x is greater than equals to x naught is equals to 0.5. Now, where do you think that our x naught should be, so that the probability that the value of x is greater than x naught is 0.5? Yes, it should be at the middle, or it should be at 29. Do you all agree? Because, so we have this 29 in the mean. So 29 is the mean. So what is the probability on the right side of 29? 0.5, right? So our x naught is the same point as 29. So our x naught, is 29. And the reason is that the probability on the right of 29 is equals to 0.5, which is given to us. So this one is easy here. So we don't need to show any calculation. X naught is equals to 29. Now let me do number B. So in number B, we are asked to find x naught, okay, such that the probability of x less than x naught is 0.025. Now where do you think we will have our x naught? Okay, we have the two options. You can have on the left or on the right. Okay, so we have these two options. But the probability that x less than x naught means less than x naught on the left side, less than x naught has to be equals to 0.025. Now, do you think that we will have our x naught on the right side of 29? So what happens if we have x naught on the right side? Is this probability or is this area equals to 0.025? No, right? It should be greater than 0.5. So x naught cannot be on the right side. So our x naught is on the left side. We don't know that yet. Okay, so we have x naught here. And less than means this area. And this area is equals to, what is this area given to us? Probability is same as the area. So this is the area, 0.025 is the area. Okay, probability is same as area. And our target is finding this x naught. Now we have to use the z table. So every time if you have a normal distribution, we always need to use G table. Okay, and in order to use G table, we need to have G value. Okay, you have to convert this X value into G value. Okay, now how do we convert? So let's convert this X value into G value. And to convert, we have formula G equals to X minus mu divided by sigma. So if you convert X naught into G, what do we get? We have X naught minus mu, which is 29, divided by sigma, which is 8. And what about 29? 29 is the mean, and mean always have a G value equals to 0, right? So this always has a 0, or you can simplify it. 29 minus 29 divided by 8, and this is 0. So 0 is the G value for 29. Now our target, so let's call the corresponding G value for X naught is G naught. Okay, and which is this expression, okay, in terms of X. Now so our target is finding this point. Okay, we need to find this G value. Now how do we find this G value? We're gonna use G table. Okay, and in order to use G table, how can we find this point here, this G naught value? Now can we find the area of this region? Okay, what would be the area of this region? What is this area? Okay, do you all agree that? So from 29 to all the way to the left is 0.5. Okay, this total area is 0.5. Okay, and if you subtract this yellow region, we get blue region, right? So this is 0.5 minus, so this is 0.5 minus 0.025, and we end up with, what do we get? Can you help me here? What is this equals to? 0.475. Now we know the area of this region. Now what we can do is that, now we look the G table and we look for the probability which is very close to 0.475. Now you find a probability very close to 0.475. Sometimes you might find the exact probability. If you can't find exact, you are looking for the closest one. So which one is the closest? 2 point, no, you just tell me the probability, not the G value. Just wait for G value. What is the value on your G table closest to this 0.475?
1.96.
So that's the corresponding G value, right?
Yes.
So what is the area for that? 1.96. Bless you. Okay, can I? Okay, just give me a second. Use your G table. Okay, so you are looking at 0.475 and you say 1.96. Okay. Oh yeah, we have exact 0.475. So 1.96 is our G naught. So G naught is, now it's on the left side. Will it be positive 1.96 or negative 1.96? Okay, it's the negative, okay? If you have your G on the left side, it's always negative. So it's going to be negative 1.96, okay? So this is also G naught and this expression is also G naught. If both are G naught, they have to be same, right? They have to be equals to each other. So now we have negative 1.96 equals to X naught minus 29 divided by 8. And the reason is that this is also G naught and this is also G naught. Okay, we converted this X naught in terms of G naught, okay, in terms of G value. So these two has to be same, has to be exactly same value. So we have this equation here. Now we solve this. So you multiply both sides by 8. 8 times negative 1.96. What is that? Equals to X naught negative 29 you're gonna add 29 on the both side, and our x naught is 13.32, and this is your final answer. And at least you must have this much work, okay, for the full credit, and you'll have one type of this question, okay. So make sure you know how to find the x naught. Now in the similar way, can you do number C and D? It's same, okay. Start from drawing a graph, okay, then make sure you have the correct region, find the g naught, okay, convert the x naught value into g naught, and it's going to be same this one, and you equate that value equals to the g value, and you solve the equation, you should get the x naught. Is it okay if I skip C and D? So I want you to try, and if you still need help, let me know. And as I said earlier, okay, you're gonna get very similar, okay, like from number 6 you will have one question. Do not expect exact same value, but this type of question, okay. Like from 5 you get one type of question, okay, and from 4, from 3 2, so you're gonna get one very similar example on your exam. Okay, now let's go to number 7. Okay, we have miraculin. That's a protein naturally produced in a rare tropical fruit, can convert a sour taste into a sweet taste. Thus, it has the potential to be an alternative low-calorie sweetener. In plant science, a group of Japanese environmental scientists investigated the ability of hybrid tomato plant to produce miraculin. For a particular generation of the tomato plant, the amount X, so X is the amount of miraculin produced, it is measured in micrograms, had a mean of 105.3, so this is our mean, okay, and a standard deviation 8. Assume that X is normally distributed. You start drawing a graph, okay, you start with a graph. Since this is a normally distributed, you draw bell shaped. Mean is given as 105.3. Standard deviation is 8. Okay. Now let's go to the question. We are asked to find the probability that X is greater than 118. Now where do we find 118? So it's on the right, right? So let's say this is 118. Now are we asked to find now what is the area we want here? Is it on the right side of 118 or left side of 118? It's right, because X greater than 118. So this is our X. So X greater than 118 means right side. So we want to find the area of this region, and this area is the probability. That's all we need to find here. Now how do we find? This is a normal distribution, so we're going to use a G table. But to use a G table, are we given a G value? Are these 105.3, 118 are the G value? No, these are the X. So we have to convert. So let's convert into G value. So 105.3, the mean always has a G value equals to 0. Okay, you can use the formula, but you always end up getting 0. Now let's convert 118 into G value. So that is 118 minus mean, which is 105.3, divided by standard deviation, which is 8. And what is this equals to? 118 minus 105.3 divided by 8. One point, or do we get 2 point? I think it should be 1 point. 118 minus 105.3 divided by 8. 1.5875. Okay. Since our G table has a 2 digits, so 1.59. Yeah. So make 1.59. So we have 1.59 for G value for this one. Okay. So our target is finding the area of this region. Now, with the help of G table, is it possible to find the area of this region? The G table doesn't give the area of this region. G table gives the area of this region. So let's find area of this region with the help of G table. So you look at a value 1.59 in the G table and tell me the probability for this region. 0.4441. Our target is finding the area of L region. Now what is the area of L region? This is the total from this point to the right is 0.5. You get rid of this blue region, we get L region, which is 0.5 minus 0.4441, and this is equals to
0.0559.
and this is the probability. So that's 0559. It's a very similar concept, okay? So like every time if you have a normal distribution, we've been doing the same thing. There is nothing difference, okay? Now in the similar way, can you find the probability that x is greater than 96 and less than 113? So I'll just give the region and I want you to try, okay? So here, so this is 105.3, 96 is somewhere here, and we have 113 somewhere here. And you are asked to find the area of this region. Can you all find the area of this region? And you're going to use a Z table. Can you find this one? It's okay. Now you just convert this x value into Z value, okay? So let's convert. So this is 96 minus mean, which is 105.3 divided by 8. This is 0, and this is 113 minus 105.3 divided by 8. Okay, so what do we have G value for 96? 96 minus 105.3 divided by 8. Okay, and what about 113 minus 105.3 divided by 8? 0.96. Okay, now you use your G table and look for the value 1.16, and that give us the area of this region, okay, not all. So what will be the area of this green region? 0.377. Now you use this G value and that will give us the area of the second region. That give us the area of this region. And what is the area? 0.3315. Now what will be the probability? Is the sum of these two numbers, right? So you add 0.377 and 0.3315 and you get the probability. And number C is very similar to number 6. Okay, you are asked to find A, so I want you to try number C, okay? And number C is very similar to number 6, the one which we just did here. Okay, okay, do you have any question for this part, number 7? And we've been just using the same concept here. You have a normal distribution, you are converting into Z value using a Z table, okay, finding the correct region, and that area of the region is the probability. No question? Okay, let me go to number 8. Aquatic biology studied green sea turtles inhabiting the Grand Cayman South Sound Lagoon. Researchers discovered that the curved carapacial length of these turtles is approximately normally distributed. See, this is normally distributed. The very first thing, you draw a bell-shaped curve. Even start, even finish. Okay, the mean is given 55.7. That's what we want. Mean is at the center, 55.7. The standard deviation is given 11.5. and we are asked to find the minimum and maximum size limits of captured turtles in the legal marine turtle fishery are 48 centimeter. So this is the minimum size 48 centimeter, maximum size is 60 centimeter. How likely are you to capture a green sea turtle that is considered illegal? Okay, now if you now here, so minimum that you can capture is 48 centimeter, right? So 48 is somewhere here, let's say, and the maximum that you can capture is 60 centimeter, somewhere here. How likely are you to capture a green sea turtle that is considered illegal? Now what area? So how likely means we are finding the probability. This is a normal distribution. Finding probability means finding area. Now what will be the correct region? So we have this different region. So are we finding the area of this middle region? Is that what we want?
No, the other.
So minimum and maximum limits for captured turtles in the legal marine are okay. So minimum means, are we allowed to capture 48 centimeter or less than 48 centimeter? And the maximum size limits. Okay, so are we allowed to capture the size in between 48 and 60? Is that legal or illegal? Capturing the turtle of the size between 48 and 60. Is that legal or illegal? Illegal, right? Or is that legal? Legal. So here, but we want to find the probability that you capture illegal one. So illegal means the region on the left of 48 and the region on the right of 60. So our target is finding the area of these two regions. So you can capture the size between 48 and 60, but you can't capture the size less than 48 and less than 60. And you are asked to find the area of these two regions. Now can you find the area of these two regions? Using the same concept. This is a normal distribution. You convert this x value into z. Okay, this is x. This is x. So you convert into z value, use the z table and find these two area. And the sum of these two area is the likelihood. Can, yes?
Like after you add those, you have to subtract it by 1, right? Like 1 minus those two to get the area of the other?
Yes, you can, yeah, you can use that concept also, because the total area is 1, okay, and in order to find these two, if you subtract this one, or but you subtract 1 from what? From this middle area.
Yes.
Yeah, once you know the area of this middle region, yeah, you subtract from 1 and you get the total area. Okay, or you can just find the area of this region separately, find the area of this region separately, and you just add. Or you just find the area of this region and subtract from 1. Okay, can I skip this one? Or you want, okay, I didn't hear anything, so I'm gonna do this one. Can I skip this one? Okay, so that means no. So let me solve this one. So we're gonna convert this x value into z value. So let's convert 48. 48 minus mean is, what is the mean? 55.7. Okay, 50, okay, it's here, 55.7. Divide, okay, and how much do we have for this one? What is the z value?
Negative 0.67.
67, and the g value for 55.7 is 0. Let's convert g 60 minus 55.7 divided by 11.5, and what is this equals to? 0.37. Okay, now use your g table, okay, and look at the value 0.67. and that give us the area of this region, okay, not the yellow region, make sure. And what is this equals to from G table? 0.2486. Now use your G table and look the value 0.37. That will give us the area of this region. And what is this area? 0.1443. Okay, so our target is finding the yellow region. So the total is 1, right? So the area under the total area is 1, and if you subtract these two regions, we get the area of these two regions. Okay, you subtract these two numbers from 1, and we have our likelihood. So the final answer is 1 minus 0.2486 plus 0.1443, and this will be equals to, what is this equals to?
0.6071.
Okay, and this is the likelihood. So 60% is the likelihood that you capture a green sea turtle that is considered illegal. Okay, now number B, find the maximum length limit L. So, okay, what maximum limit L should be set so that only 10% of the turtles captured have cell lengths greater than L. Okay, now here, so let's start from a graph. So we have a normal distribution. Our mean is 55.7. Now what are we asked here? We are asked to find the length. It means, let's say our length is on the right, or it might be on the left, but we need to figure out that. So find the maximum length that should be set so that only 10% of the turtles captured have cell lengths greater than L. Now what does that mean? So the probability is 0.1, right? So the probability that length is greater than this L is 0.1. Now will this L be on the left side or right side? Is yes, because the greater than means, so this region, so the probability of this region is given as 0.1. So we can't have length on the left side. If you have on the left side, the probability has to be greater than 0.5. So this is 0.1. Now isn't this the same example as like number 6? See, it's exactly same like in number 6. It's very similar. So you are finding x naught. Okay, mean is given. So what you do here is that you convert this L into G value, which is L minus 55.7 divided by standard deviation 11.5. The G value for this one is 0. Okay, now our target is finding the G value for this point using a G table, and in order to find that, we should know the area of this region. How do we find this area of this region? Yes, this is 0.5 minus this yellow region, which is 0.4. Now you look at your G table and look for the probability very close to 0.4. That's the G value. Okay, so this is 1.28. So this 1.28 and this is exactly same, so they have to be equals to each other. Now you solve this and find L. Okay, so nothing new, it's the same graph, same concept. Okay, can I go to the next one? And you will get very similar. Okay, do not expect exactly same, but you will get very similar example on your exam. Okay, now we have number 9 here. Okay, so we have this probability distribution. Okay, and this probability distribution describe the measurement that can assume values 1, 3, 5, 7. Okay, so we have this distribution where x takes a value 1, 3, 5, 7. So x can be 1, x can be 3, 5 or 7. And its probability is also given to us. Now calculate the mean of all different sample of n equals to 2 measurement that can be selected from this population. Okay, now you have this option 1, 3, 5, 7. Now how can you select 2 number out of this 1, 3, 5, 7? You have these 3 option, and you won't get 3 option. You won't have these 3 options on your exam. Okay, you might need to find. Now you have 1, 3, 5, 7. Now in how many ways you can select 2 number from 1, 3, 5, 7? How? So you have a 4 option, and you are selecting only 2 number. So you can have 1, 1, right? You can select 1, 2 times. So you can select 1, 3, 1, 5, 1, 7, okay, 3, 3, 3, 5, 3, 7, or 3, 1, okay. You can select 5, 1, 5, 3, 5, 5, or 5, 7. And you have you can select 7, 1, 7, 3, 7, 5, or 7, 7. And which option is the correct one? A, B, C.
B.
Is it A or B?
B.
It should be B. Okay, because okay, let's start. So you have 1, 1, 1, 3, 1, 5, 1, 7. Then 3, 1, 3, 3, 3, 5, 3, 7. Then 5, 1, 5, 3, 5, 5, 5, 7, 7, 1, 7, 3, 7, 5, 7, 7. Okay, you are listing every possible ways of selecting 2 number. Okay, out from those 4 number 1, 3, 5, 7. So B is the correct. Now you are asked to find the average x bar. Okay, if you have 1, 1, what is the average of 1 and 1? 1, right? Okay, so it's 1. So what is the average of 1 and 3? 1.5, right? Sorry, it's 2. 1 plus 3, 4. 4 divided by 2 is 2. 1 and 5, that is 3, right? 1 and 7, that's 3.5. So that's 3. Oh, thank you. 1 plus 7, 8. 8 divided by 2 is 4. 3 plus 1, 4 divided by 2, 2. 3 plus 3, 6 divided by 2, 3. 3 plus 5, 8. 8 divided by 2 is 4. 3 plus 7, 10. 10 divided by 2 is 5. 5 plus 1, 6 divided by 2, 3. 5 plus 3, 8. 8 divided by 2 is 4. 5 plus 5, 10 divided by 2 is 5. 5 plus 7, 12 divided by 2 is 6. 7 plus 1, 8 divided by 2, 4. 7 plus 3, 10 divided by 2, 5. 7 plus 5, 12 divided by 2, 6. 7 plus 7, 14 divided by 2, 7. This one is easy, right? Okay. Now, if a sample of n equals to 2 measurement is randomly selected from this population, what is the probability that a specific sample will be selected? Now you have this sample, okay? So you have 1, 2, 3, 4, 5, 6, 7, 8. So you have 16 sample. Now out of 16 sample, what is the probability of selecting one specific sample? So you have a 16 ball, different ball, okay? You can just consider a ball. You have a 16 sample and you are picking one sample out of that 16. So what is the probability? 1 over 16. So 1 over 16. 1 over 16. Okay, number C, we have to complete this sampling distribution. So we have to form a sampling distribution. Okay, now your sampling distribution takes a value of x bar, okay, not x. Okay, now what are the x bar values? We have 1, 2, 3, 4, right? 5, 6, 7, and there is a repetition. So we have 1, the next x value is, x bar is 2. We have 3, 4, 5, 6. So you are using x bar. Now what is the probability that you have a sample? What is the probability that our x bar takes a value 1? So how many times x bar takes a value 1? one time, right? And the probability is 1 over 16. So we have 1 over 16. So this is 1 over 16. Now what about 2? It's given 1 over 8. But how do we get 1 over 8? So x bar takes a value 2 times, right? So it's here and here. So 2 times means 2 over 16. So 1 over 16 plus 1 over 16, 2 over 16. And in the simplest form, it is 1 over 8. Now what about 3? So what is the probability that x bar takes a value 3?
3 over.
So how many times it takes 3? 1, 2, 3. So 3 over 16. So that's 3 over 16. What about probability that x bar takes 4? 1, 2, 3, 4. 4 divided by 16, right? 4 divided by 16, and which is 1 over 4. Okay, for 5 it's the similar way. So 5 is 3 times. So it's 3 over 16. 1, 2, 3. 6, 1 over 8, because 2 times, I think, yeah. 1, 2. And 7, what is the probability that x bar is 7?
1 over 16.
It's just, so 1 over 16. And you're going to have the very similar question, okay? Very similar. So make sure you know how to solve this one. In number D, you are asked to construct a histogram. It's super easy, right? So histogram, you have a x bar on the horizontal axis, and you have the probability of x bar. So x can be 1. So this is 1, 2, 3, 4, 5, 6, 7. So these are the values for x bar. And our probability is 1 over 8, 1 over 16. Which one is the smallest here?
1 and 7.
Is the 1 over 16 the smallest value? So, okay, this is 1 over 16. Then what is the next smallest? 1 over? Is it 3 over 16?
No.
1 over 8? Okay, 1 over 8. Then 3/16. Then 1/4. Okay. Now you draw a bar. So when 1, the probability is 1 over 16. So you draw a bar of the height 1 over 16. When it's 2, 1 over 8. So 1 over 8 is somewhere here. When it's 3, is 3 over 16. When it's 4, is 4 over 16. Oh, that's 1 over 4. When it's 5, 3 over 16. When it's 6, 1 over 8. When it's 7, 1 over 16. That's the histogram. And you will have very similar question on your exam. And I think, okay, do you have any question for this number 9? If you don't have any question, you should be able to do number 10, okay? I will leave this for you. So you have to find the x bar for each sample at first, okay? So for each sample, you find the x bar. So these are the sample, okay? And you are writing the values that x bar takes. So some of them are given to you, like it takes 4.5, 5, 6.5. You have to find the remaining x bar, and you have to find the probability. Can you just do number 10? So if you have 4, 4, what is the x bar? It's going to be 4, right? So you find the x bar. So this should be 4. You find the x bar for each sample. Okay, write down here, and you find the corresponding probability. Can you solve this number 10? And if you can't solve, just write me an email. Okay, I'll just reply you. Okay, in number B, you construct a histogram. Now once you fill this table, you'll have the table very similar to this number 9. This C. Okay, you construct a histogram like the one we did. In number C, what is the probability that x bar is 6 or larger? So we might get 6 here. Do we get x bar equals to 6, Kayla? Okay, so this is 6.
There's no line, so it's greater than 6. So 6 doesn't even matter.
Can you repeat that?
It's not equal to 6. So 6.
So x bar is 6 or larger.
Or.
So you have so you want to find the probability that x bar is 6 or larger, means you are adding the probability of 6 and larger value. So you are adding 0.28, like whatever value you get here and whatever value you get here. That is your probability. Once you fill this table, you are adding 0.28, you add this number and you add this number. Okay. So out of 9 and 10, you will have one on your exam. So make sure you know these two. Okay, now here, so we have, okay, now this table was missing, and you can find this table on your MyMathLab as well, okay? So I want you to copy this one, and you are asked to find the expected value, and you all know how to find this expected value, so I'm not solving this one, okay? I will give you formula to you. Okay. You can practice from the table on your that you can find on a MyMathLab, okay? So you are asked to find E of x. So E of x is, what is the formula? Summation of x times P of x. So you take each value of x, multiply by its probability, and add 2 times 0.2 plus 3 times 0.1 plus 4 times 0.2 plus 5 times 0.1. N number, and you are also find E of x bar. And E of x bar is summation of, you are multiplying each value of x bar with its probability and adding. So you multiply 1 and 0.16 plus 1.5 times 0.16 plus 2 times 0.12 plus 2.5 times 0.2, and you do for all x bar. Now, how will you, okay, now here's the question thing. Now, if you are asked whether x bar is the good estimator or not, or like if your x bar is biased or unbiased, how do you know that? So you have x bar. Now, how are you gonna know x bar is the biased or unbiased? Once you calculate these two values, you should have the conclusion. So if you get exactly same value, x bar is unbiased estimator. If you get different, if these two are different, then they are biased. Okay, that's the conclusion. So every time if you are asked to check whether your estimator is biased or unbiased, you are finding the mean of the population. You are finding the mean of a sampling distribution. If the mean of a sampling distribution is equals to mean of a population, it is unbiased. Okay, if these two are different, then it is a biased estimator. I forgot to add that question. I'll be adding this one, whether x bar is a biased or unbiased. Okay, but once you have these, once you know the mean for population and a mean for the sampling distribution, you are just writing in one statement. Is it yes or no? Do you have any question for this number? And I'm hoping that you know how to find the expected value, okay? You are taking each value of x, multiplying with its corresponding probability, and you are taking sum. Okay, number 12. Now here, this, okay, you have one type of question, okay? You will have one problem very similar to number 12. So our n is given 25, okay? This is the population size. Mean of a population is given as, so for number A, mean is 13, standard deviation is 3. And we are asked to find mu of x bar and sigma of x bar. Now, according to the property, we have the mu of x bar is always equals to mu of population. Okay, so if this is the case, what will be the mu of x bar? It is 13. And the standard deviation of x bar, it is equals to standard deviation of a population divided by square root of n. Standard deviation is 3 divided by square root of n, which is 25. So we have 3 over 5, and that is 0.6. And you do the same thing for BCD. And you will have one question out of this ABCD.
And if we're asked to do the variance, it's the same thing but backwards, right?
You are not, I mean, once you have the standard deviation, you can find the variance, but you are not asked to find variance here. Okay? So variance is the square of the standard deviation. If you square 0.6, you find the variance, but you are not required. And so do not expect this, okay? I don't think that, I'm not sure on your formula sheet you will have this or not. But yeah, so if you are asked to find the mean or standard deviation for x bar, the mean is same as population mean. Standard deviation is equals to standard deviation of a population divided by square root of n. That's for number 12. Okay, number 13, very similar. Mean is given 29, n is 100, sigma is 23. You are asked to find mu of x bar, which is same as 29, and sigma of x bar, which is 23 divided by square root of 100. Describe the shape of sampling distribution. So what will be the shape of this sampling distribution? And it is given by central limit theorem. It's going to be d approximately normal. Okay, so make sure you know the central limit theorem. Okay, because our n is greater than 100, and if your n is our n is greater than 30. If your sample size is greater than 30, the sampling distribution will always have a normal distribution. Okay, and the remaining B, C, D, E, F, it should be very similar to the one that we did earlier. So once you have the normal distribution, you are using the G table and finding the probability. Number 14, very similar. Sigma is given, standard deviation is given, similar to number 13. Okay, sample size is, what is the sample size? 100. So it's gonna be approximately normal, and BCD should be very similar to the one that we did earlier. So basically normal distribution. So if you understand the normal distribution concept, you should be able to solve almost every problem. Okay, and there will be a multiple choice question. So make sure you go through your lecture notes. You are not required to memorize the definition, but you should know the concept. So there will be I think there is 11 multiple choice question, and the remaining are calculation. And calculation are very similar to this review. Okay, you will get exactly same type. The number may be different, but you will get exactly same type, the calculation. But for the multiple choice question, you have to read your lecture notes, like a definition. Okay, you are not required to memorize. Just make sure you read at least once, like the central limit theorem, like the what is statistic, or like what is the difference between statistic and parameter, or what parameter tells you. Okay, so make sure you read the lecture handout. Do not memorize, and practice these problems. So problems will be very similar. Okay, like as I said earlier, like you will have out of 13 and 14, you get one type of question. Okay, like from 12 you get one question. Number 11 you get one type of question. Out of 9 and 10 you get one question. The numbers are different, but you're gonna get exactly same type. Okay, and you can find this question on your MyMathLab, and if you do MyMathLab, you get the extra credit. Okay, so let's do this much for today, and we are done with the review. And if you have any more question, write me an email.